All right, so today's lab, obviously there's no procedure in the lab notebook or in the lab manual. Um, and that's on purpose. The whole point of doing this lab is kind of going more kind of behind the curtain, trying to see like how exactly do you come up with an experiment to test out a hypothesis. Like so far, everything has been kind of spoon-fed to you. Um, Typically, like when we're in person, we actually have these independent research projects where people actually come up with their own objectives and have to design experiments. So in that case, doing this together is kind of like taking the training wheels off and kind of getting you more used to just working more freeform. But it's still, even when we're doing the COVID era lab, it's still, I think, really useful to see how you have to think about kind of designing experiments and kind of what goes into that. So, without further ado, I'll introduce the Rods and Cones Lab. So most people have actually done the rods and cones, personal experience, although some of you didn't. Again, if you haven't, please do it. It's actually really useful to get a real experience of what rods versus cones really feel like, or what they are like, and also its points. So let's start with just people's experiences of rods versus cones. So if we're thinking about rods versus cones in terms of vision, how are they different from each other?
Cones are high acuity and rods are low acuity.
Mm-hmm. High acuity, rods were low acuity. And most people in their little reports did write that they could read words in the brighter light, but when they were really in the dim light and rod vision, you can't make out words on a page. Those of you who did say, I could see the words, but I had to strain, or you weren't actually using your rods. If you were just using your rods, they don't have the ability to make out something as fine as the spacing of a letter. So if you could make out, like, make sure you don't walk into a table, but you can't read like a word on a page, then you're in rods. The same thing with colors. People said, in the bright light, the colors were bright, but in the rods, the colors were not as bright. It's like, no, if there were colors, you were in cones, right? If you were just using your rods, you would not experience color. You would just see shades of gray. So just kind of making sure you kind of keep that in mind when you think about what are rods. They are active and very dim. In fact, most people, if they did it right, said when they first made the lights go low, they couldn't see anything, right? Because your rods get bleached. This is actually going to be important for today's lab. Like right now, when you're just in normal bright light, the rods are so overwhelmed that all of the opsin has been, or all of the retinol, I should say, has been like um, sprung into the, kind of trans conformation. So when you first turn the lights down really low, all the rods are now just bleached, we call it, and they can't do anything. It takes them a little while to regenerate themselves and get all of the, we call rhodopsin, the retinal and opsin molecules ready to go now. So you can actually start having them function in the very dim light. So when you first turn the lights off, it looks black. You don't see anything. But then usually after a few minutes, you start noticing, oh my God, I actually do see the really dim light. Now the rods are coming online. In general, within about 5 minutes, They have what we call dark adapted pretty well. You can, after 5 minutes or so, you can actually see pretty well in the very dim light. Although they keep getting better, like up to like 20 minutes or more after you get into the really dim light.
When
So,
you say see well, do you mean like if I could see color when the lights were off, does that mean it wasn't dark enough?
yes,
Okay.
yes. So, so thinking about rods and cones, one of the other things that differentiate them that we haven't talked about, but is going to be important for today's lab, is that cone vision is processed more quickly. Rod vision is processed more slowly. So this is, I mean, for a number of reasons. Partly just because for rods, you have to like gather data from lots of rods and converge it and take it in and try to figure out if something's going on there. Whereas the cones have this strong signal that's coming straight through. So this is going to be important for today's lab when we're coming up with our hypothesis. You know, the whole deductive reasoning for a hypothesis. This is going to be one of the previously known things that we're going to use. This is just a given. We know that vision that is mediated by rods is going to happen more slowly than vision that is mediated by cones. So this is going to be an important part of today's lab. So kind of this, is everybody clear what I mean by that? So then we can put this in the context of a visual reflex, which is what we're going to be looking at today. Right, a visual reflex is just a reflex. What are the three components of a reflex arc?
You got your stimuli, and then you got your afferent efferent neurons and CNS, and then the effector.
Yeah, so there's stimulus, there's integration, and then there is the output, the response. So that's your classic. If it's a visual reflex, then all that means is that the stimulus is a visual stimulus. There's some, which then sends the message in, and there's some response out. So that is the definition of a visual reflex. It's just, we've seen them already, right? The pupillary reflex was a visual reflex. You shine a light in your eye and your, iris constricts. So what we can do now is think about this. So if rods, which are functioning in dim light, and cones, which are functioning in bright light, if rod vision, so think about, in dim light, you are using rods, and rods process that visual information more slowly. In bright light, you are using cones, and cones can process the information more quickly and respond more quickly. Maybe I should say process, they processed and respond more quickly. So if we go back to my visual reflex, what do you think is going to be the effect of just the level of lighting, the brightness of the lighting around you on the speed of a reflex?
The brighter it is, the quicker the reflex.
Yeah, exactly. So if we come up with a objective, if I'm curious about Yeah, I'm going to have some objective, which is going to be an independent variable. Let's change just the brightness of the light that I'm in. My dependent variable is going to just be the speed of this visual reflex. Then what Chris is saying, exactly, if the light is brighter, you're going to be using cones. Cones process faster, which means this whole thing from start to end is probably going to happen faster, right? What if I'm in dim light? What if the light is dim?
There's less stimuli, so it'll take longer to elicit a response.
So less stimuli. Let's say there's less the
There's less
light,
light, yeah.
less light, which means what? You need to kind of make sure you have all the parts in place.
Is there like a certain amount of light that's needed to reach the threshold to create a response?
I mean, there is that, but it's different in the different kinds of photoreceptors. So you should be bringing this back to our initial discussion of photoreceptors. If I'm in dim light, which photoreceptors are being used?
The rods, and they converge. Don't a lot of rods converge onto one axon, whereas the cones have each individual, or not axon, each individual nerve, I guess, per cone.
Right.
I'm not saying that
But
right.
still, I want to kind of, so that is true. But kind of, since we're talking about the speed of a reflex, what we were kind of more interested in is how fast are these guys working, right? So again, we're coming back to this. Like I said, this is going to be the key information that's going to be helping you kind of with your hypothesis here, right? So if I am in dimmer light, which photoreceptors are being utilized?
Rods.
Rods. And rods are processed
Slower.
more slow. So if we're going to look at the overall speed of stimulus to response, if it's taken longer for just this to happen here, it's going to take longer for the whole thing from start to end. Does that make sense? Because this is what I'm kind of laying out right now is kind of the objective. In fact, in a nutshell, just as a quick little sentence, what would be a nice statement of the objective of this lab that we are kind of creating here?
How does the brightness of the light affect the speed of the response?
Right, or there's the speed of the whole visual reflex. But yeah, exactly. So that would be the objective for this, right? And then what would be a hypothesis, given what we've just been saying? What would be a reasonable hypothesis?
The brighter the light, the faster the speed of the visual reflex. Because cones are processed more quickly.
Right, so you've got you're on the right. You've started, and you want to be kind of more complete. You want to have all the different pieces. So if you wanted to say it completely, how would you say it?
Because the cones are processed more quickly and the rods process slowly.
And then you have to include the brightness of the light in there, right? Because ultimately we're saying, how does brightness affect the speed of the reflex? So if you wanted to kind of say it, like really put it all together.
So that the cones like use the bright light, or they process the bright light, so therefore
Right.
the bright light processes faster.
Right. So if you're using, if the light is brighter, you're in cone vision, and cone vision is processed faster, so we're going to have a faster reflex. If we're in dim light, what photoreceptors are processing vision in dim light?
Rods,
Rods. So then what would that imply?
slower processing.
Yeah, because again, that's our given. Our given is rods process more slowly, and therefore, what are the implications for the overall speed of the reflex?
That it's slower.
But it's slower. Right. So for your hypotheses, though, you need to make sure you connect all the pieces, right? Under this condition or that condition, which photoreceptor is actually mediating the phototransduction, and then how does that affect the overall speed of things? So, you know, in a few minutes, we're actually going to go into breakout rooms where we're all going to be writing our objectives and hypotheses and actually the entire methods. But obviously, the first part of writing, doing up a lab, is have a really solid objective and a really kind of clearly stated hypothesis. All right, so now we have this objective. How does the brightness of the light affect the speed of this visual reflex? We have a hypothesis. Brighter is gonna go faster because bright light's gonna be cones, and cones go faster, and dim light or rods and rods go slower. And now we need to come up with what we call like the critical experiment. We need to come up with an experiment to actually test and get some data to see if our hypothesis is supported or not. And that part is, kind of tricky. It's actually worth, before we actually design the experiment, it's worth thinking about sources of variability, because that's actually going to be important as we design our experiment. We want to make sure we design our experiment so sources of variability are minimized. Like, what are sources of variability in this?
Brightness of the light has to be uniform when testing everybody.
Right. So yeah, so you should have, in this experiment, the instructor is the one who actually controls the brightness of the light. So we're going to have actually 5 conditions. We're going to have light sources that go from what we call super bright to medium to dim to super dim. So you can assume that that is being controlled because it's the instructor is setting up the lights. What are other sources of variability besides how well you're kind of controlling the brightness?
Would individual sensitivity be one?
Right, individual, right? Any kind of reflex. We saw, everybody is a little different. So how can we deal with the fact that everybody is a little different just in how they're going to respond to things, how fast they would do a reflex under the same conditions? Right? If I do some visual reflex under the exact same lighting as, see, like Amato's up there, as opposed to Lily, we would all have probably slightly different speeds that we accomplish the reflex at. So how can we get around that?
Don't you compare like the individual's data to their data?
Yeah, so we can do what's called like a within subject control. So for the same person, test them under the 5 different lighting conditions and see how that affects their speed. So even if they're kind of just naturally faster or naturally slower, it doesn't matter. We can still see relatively how does their speed change from dim to bright. And then there's also the issue where we saw, like with the jumping lab, right? If you do the exact same thing again and again, you probably don't do it exactly the same. So how do we get around that?
take, have them do multiple trials and then take averages.
Yeah, exactly. So that's, we're going to have to think about that. That's another source of variability, is just people don't do a particular thing exactly the same every time. What are other sources of variability?
Would time of day be one? Like your rods and cones are more adjusted in bright light than if it was like foggy outside, the light might be different.
So they're going to be adjusting to whatever the light conditions are where you are in the moment. But something that's relative or relevant there is, if you are in if you are in some like bright light and then you're testing in some dim light, what might be an issue?
It will take some time for the to adjust.
Yeah, exactly.
You have bleach, right?
Yeah, exactly. The
Bleach.
rods are probably bleached. So that's another source of variability, is rods get bleached. So we're going to have to make sure, if we're ever going from brighter light to dimmer light, that we allow enough time for the rods to adapt, dark adapt, we call it. Now that's going to have to be an explicit part of our methods. What are other sources of variability, especially given that it's a visual reflex? You're going to have to see something that's going to tell you that it's time for the, to respond.
Can there be like a degeneration of the auditory system or nerve, the individual degeneration of the rods or cones?
So anything that affects your vision is going to probably be a source of variability, right? Right. If it's a visual reflex, if your vision is compromised, that's going to mess up your results. Right. So, when we are specifying our subjects here, we need to be explicit. Don't just say, let's take a random person and start the experiment. We want to make sure that they have, usually in an experiment like this, you say 20/20 or correct it to 20/20. Right? So that's a source of variability that's off the table. We know that whatever else is going on, it's not just because the visual target is blurred out beyond recognition or something. Right? So we make sure that we have to say this explicitly. If we don't do this, then when you're doing the experiment, you might not have checked. And then after you're done with everything, someone's going to say, like, how do we know that they just were blind and couldn't even see the target? And it's like, I don't know. Okay, we got to throw out the experiment and do it again. So things like that. Other sources of variability. So we'll come back to this after we get a little more detail, because so far we've come up with our independent variable. Our independent variable is just going to be how bright it is in the room, which is going to be adjusted by the instructor using lights. So our independent variable, that one's easy. The dependent variable, the speed of the visual reflex, we haven't come up with an actual visual reflex to look at yet. So we need to actually come up with some reflex if we're going to do this experiment. So what are some possibilities for a visual reflex in this case? And this is the part of, where you kind of brainstorm, right? You have to just think, what about this? Does that work? Yes, no.
Maybe the size of their pupil, whether it's constricted or dilated, to let in more or less light.
So, right, that's a visual reflex we've already looked at. That could work. We could see how long it takes their pupil to change size. The problem with that one, especially given the equipment we have, that's going to be really hard to measure, right? watch, seeing some little change in the pupil, and actually we got to time it when the light came on and when the pupil changed size. It's possible to do if you have all sorts of special cameras and computers measuring things. But for our lab, we're going to stay really low tech. So while that could work, and that's a good suggestion, given that we're in just kind of a lab filled with sticks and rulers and tape measures and things and little timers, it's probably not going to work for us. In fact, most of the more fancy ways that could be kind of fun to do aren't going to work for us because you need more complicated sensors and computers and things like that. So there's actually in fact, I don't know, I can. I don't know if this is something we always did as when we were younger. Has anyone ever done that thing where someone like holds a dollar bill, and if you can catch it, you get to keep it?
Yeah.
Yep. That's a visual reflex, right? As soon as the thing is dropping, you try to grab it, right? So the stimulus is I see the bill dropping. The response is I'm trying to grab the bill. And that it's something that we can actually adapt pretty easily for our lab in a way that's really low tech, but actually allows us, because part of the problem in this is we're looking at the relationship between kind of brightness, versus the timing of the reflex. There'll be a difference, but it's going to be like fractions of a second. It's not something you can watch and start a timer, stop a timer. It's a very, very short distance of time. So one thing, in fact, the way we set this up is basically this. This is where I also feel kind of bad you're not in lab, because this is actually fun. You actually get to stand on top of the tables in the lab. So you have one person who's like the stick dropper. Here we can be Chris. He's holding, we have a stick. We actually just use like a broomstick, like a broom handle. And the only thing special about it, it has a little high contrast marking on it. We want it to be high contrast because if we're going in really dim light, you're not going to be able to see something subtle. So we're going to have a very obvious thing that even in rod vision, you're going to be able to see this thing going from dark to light to dark in a real obvious way. And then we have our subject. Oops. They're going to be looking at that mark and standing here, their hand kind of ready to go. They're actually standing on the ground. And basically, as soon as the stick is dropped, this person here kind of waits. As soon as this guy sees the stick dropping, he grabs it. So it goes from here, the stick starts going down, and his hand reaches and actually grabs it. Right, because the stick is dropping, so it's fell down a bit. The little mark is now below where it used to be. And we can actually look at this distance. How far did it fall before he was able to catch it? Right, so the longer it takes to grab, the farther it will fall. right? If the reflex is quick, the timing of the reflex is quick, he'll grab it closer to the line. If he grabs it further away, it's going to be farther from the line. It's going to have fallen farther down. Right? Does that make sense? And then one of the really, if you've taken physics, you know this. If you haven't taken physics, I'll just tell it to you. There's a really simple relationship between how far something falls due to gravity in a certain amount of time. Right? Something that's falling due to gravity is just always accelerating at 9.8 meters per second. Right? It doesn't matter if it's weighs a lot or weighs a little. It's always falling at the exact same acceleration. And so basically, this x here, the distance that it's falling, is just going to be 1/2 g t squared, where t is the time in seconds. And g here, g is acceleration due to gravity. G equals 9.8 meters per second squared. So this is like this simple relationship. Basically, if this thing fell for an entire second, like 1 second, it will have fallen about 5 meters. So you can just, if we measure the x and we know the x and we want to know the time, you just flip the equation around. The time is just going to be the square root of 2 times that distance divided by g, divided by 9.8. Right, so what's nice about this is even things that differ by a fraction of a second are things we can actually measure and get timing for, because a fraction of a second is still a few centimeter difference. So it's very low tech, but it's actually really, really nice because it's getting it exactly what we want. It's actually going to give us pretty accurate results in terms of the timing without fancy tools or equipment. In fact, one of the adjectives that's often used in experimental design is if an experiment is elegant. I would say like this is a very elegant way to test, our experiment, because it's using very simple equipment. There's very little that can go wrong, and we're actually going to get data that's going to have, good accuracy in terms of the timing, which is what we're interested in. So this our stick drop here is going to be how we're going to test. Basically we're going to have the stick drop happening, and we'll do it in those 5 different light conditions. We'll have our subject do it in the bright light, in the dim light, in the dimmest light, in the medium light, and in each case, we're going to be able to find the time. And then we can just compare. How does brightness of light compare to the timing of the reflex? So is there any questions about this? So next, we now have more sources of variability that we need to think about before we actually write up the details of our experiment. We've already said, make sure your subject has normal or corrected to normal vision. We already said, repeat the reflex 3 times to get the average, because each time it's probably going to be a little different. We said get all light levels with the same subject so we can deal with the variability of how fast any one particular person does reflexes. What are other sources of variability now that you're kind of looking at this that we need to make sure we formalize into our procedure?
Won't you need them to be like really paying attention?
Yeah, totally.
Give them like a window or explain it to them.
So exactly. So it's just like we saw in the nerve stimulation lab. You want to make sure they're really paying attention, but they don't know exactly when. So like a window saying, get ready in the next 5 seconds, it's going to drop, but you don't know exactly when. But you do know that they're really keeping their attention, so that's going to be a formal part of your procedure that you need to write down. Again, you are all going to go into breakout rooms in a few moments, and you're going to write up this formal procedure. So you need to make sure that your stick dropper, tells the subject, to get ready and gives them like a 5 or 10 second window before the stick drop happens. Good. What's another source of variability?
I was also thinking that the stick dropper needs to make sure they're just releasing the stick and not like adding any acceleration downward.
Exactly. So this equation that I gave you here, this is assuming that the movement of the stick is purely due to gravity. If this person here actually gives it a little lift or gives it a little push down, then this equation no longer holds. So you need to make sure, again, written in your procedure, that the stick dropper is holding the stick very lightly and allows it to drop without imparting any additional velocity up or down. You have to just allow it to start accelerating purely due to gravity, or else we're not going to be able to convert the distance into a time. So yeah, no, that's a good one. What's another source of variability here? Any?
I'm not sure if it's a source of variability, but where are we measuring the line? Like from where on their hand? From like the top of their hand or from the bottom of their hand?
Right, so that's a good one. You want to make sure you're consistent, right? Typically, what you end up doing is, if here's the little, it's just actually a piece of tape. If they're, kind of the webbing of their hand is kind of right at the top of that, then after the stick falls, wherever they've grabbed it, make sure you're gonna measure from there to, again, exactly relative to where they were keeping their hand. So you need to make sure that you're consistent wherever their kind of the webbing of their, between their fingers is with relation to this piece of black tape. Make sure that you measure exactly that distance from the same spot on the tape to the same spot on their hand. So yeah, so that's important as well. And while we have this beautiful picture here, this what an ugly picture. What's another source of variability, especially before the stick actually drops? What do you have to make sure about? Right.
The person is grabbing the stick in the right location.
So yeah, we want to make sure that their hand is in the right location. We also want to make sure that they're not actually grabbing it yet, right? We need to make sure that the stimulus is a visual stimulus, not a tactile reflex, like they feel something starting to rub their skin. So you need to also be explicit. You're close, but not touching. Right? If you were touching, then it's not a visual reflex anymore. Now it's a tactile reflex. It's not until you actually see the stick dropping that you grab it.
So they already have their hand in that position. It's not like
They have it close. Yeah,
Okay.
that's why I'm writing really sloppy. Close, but not touching. Right, so yeah, you want it close, but you don't want it actually touching. There's one other big source of variability nobody's mentioned yet. Now we have our subject here doing this thing 3 times in each condition and doing it in 5 different conditions. Now, what happens if you keep doing the same thing over and over again? Some new task you've never done. Especially in terms of speed of something. Or anything. You keep doing the same thing again and again.
You're gonna
You can get
Say it again.
you can get conditioned and kind of get better at it.
Yeah, you get better. You learn. Right? Practice. You get better when you practice usually. So that's another source of variability. Like the more you're doing this thing, probably, there's a chance that, in fact, not even a chance, probably for sure, the more you do it, the better you're going to get. So we need to figure out how can we control for practice, make sure, right? Because, like, for instance, I'll give you a worst case example. Worst case example, I think, okay, I'm super clever. This dark adaptation is a pain in my butt. So let's not worry about dark adaptation. Let's just start super dim, and to dim, and then the medium, and then to bright, and then to super bright. Right? I never have to wait 5 minutes for my eyes to dark adapt because I'm never going from brighter to darker. All right, and then so this is going to be trial 1, 2, 3, 4, and 5. And I get my data. And I look at my data here. This is trial 1, 2, 3, 4, 5. So this is going, and then I look at my timing of the reflex. How long did it take? And let's say I get something like this. I'm like, stoke, look at that. Took a lot longer in the super dim and it was way faster in the super bright. What could somebody else say to me? What's another way to interpret this data here?
You've had 5 chances to get faster.
Yeah, by the time you're in trial 5, you've already done it 3, 6. You've done it like a bunch of times. So how do I know you're not just better because you've had more practice? There's no way to tease apart those 2 variables. If I design my experiment like this, there's no way to satisfy somebody who says, how do I know it's not just about practice? This could just be practice. This isn't about the light at all. And you say, I can't say because I designed my experiment poorly here. So how could I get around that? How could I design my experiment so I'm going to be able to disconnect practice effects from brightness?
Could you do the trials in a random order?
Exactly. In fact, normally if we were in class, we would actually come up with it together. But since I'm going to be giving you data from another class, I'll give you the order that the class came up with when we did it. And basically the data that you're going to have for trial 1, 2, 3, 4, and 5, it's going to start with medium, which we're going to call light level 3. Then it goes to the super bright, which we call light level 5. Then we went to dim, which was 2. Then we went to bright, which is 4. Then we went to super dim, which is 1. So we randomized this. And now what we can do is we can look at the data from 2 different viewpoints, right? We can make 2 different graphs. I can do so this is the timing of the reflex. I could do it in terms of trial number. 1, 2, 3, 4, 5. Or I can also look at the data and graph it differently. Look at the time in seconds, but do it in brightness. From like 1, 2, 3, 4, 5. And one of them, assuming one is important, one of them is going to do this and the other one's going to be looking all weird, right? So I now have disconnected brightness from trial number. So I can say for sure, no, look, if we look at it just in terms of how many times they've done the task, it actually, that wasn't getting better. But if we look at brightness, irrespective of trial number, we see a real effect, right? So this is a really important thing in experimental design, is to try to dissociate different variables so you can know definitively like which variable is actually important and which one is not. So does that make sense? Right, because this practice effect is a real source of variability. You probably, just to give that, make sure that they try doing it a few times before they actually start getting real data, just so you know that they're comfortable with the task. That should probably be in there. Like, do the experiment or try the reflex a few times before you're actually getting real data, to make sure your subject has a good feel for what they're supposed to do. They're not like, wait, what is going on? Right? So you really feel more confident it's about the lighting and not about like they don't know what they're doing with the task. All right. So so here, maybe I should go to modules so you can see where I'm at. So under rods and cones lab here, it says rods and cones lab accessory material. Just kind of reminding you about rods versus cones. And this is kind of showing you what the room looks like when we're actually doing the experiment. It's basically somebody on the desk holding the stick. Here we have the subject grabbing the stick. This gives you that little formula I was telling you about. I can just show you this really quickly. It's just a broom handle with a high contrast marker near the bottom here.
A meter stick, pen light, or when the trials are very lowly lit room, need a pen light to measure the distances.
All right, so I'm the stick dropper and
I'm the stick catcher.
And so the idea is I will drop the stick, and as soon as the subject notices that it is moving, she will grab the stick as fast as she can. Yeah, and it's a purely visual reflex, so we need to make sure she's actually not touching the stick before we start, otherwise it will become a tactile stimulus. As a stick dropper, I want to make sure I'm holding it so she can hold her hand out at a comfortable level, and that her webbing of her finger is right at the level of the marker. So that way we can measure accurately how far the stick fell before she grabbed it. Also, as a stick dropper, I want to make sure that as I drop the stick, that I don't impart any initial velocity, either lifting or pushing down, because then the formula for calculating the amount of distance fallen during a certain amount of time will no longer be valid. Also, another source of variability, we want to make sure she isn't expecting it, grabs it just because she knows it's going to happen, but we also want to make sure that she's paying attention and isn't just mind wandering. So I'm going to give her a window of, like, a 5-second window of get ready, and it'll drop sometime in then, so she's paying attention, but she doesn't know exactly, so she has to use the visual cue as the stimulus. So here, we'll demonstrate it right now. All right, get ready?
I'm ready.
All right, so probably want to just practice a few times. Before you actually start getting real data, have your subject kind of get used to the task. Ready? Yep. Eventually, we're going to want to actually get data. So I can show you if you want to actually figure out how far it fell. Here we go. You ready?
Okay.
Now we're gonna have her actually measure, because normally you have another person, but it's a time of coronavirus. So again, from the web of her finger to where the black mark is, where the web of her finger was when we began. That distance is the distance that it has fallen
In centimeters.
in centimeters. And then we can use the formula. The distance fallen is just 1/2 gt squared. And we can calculate accurately then exactly how many seconds it took before she grabbed it.
I'm not getting in focus.
All right. So hopefully that kind of makes it clarifies it as well. And that formula I gave you assumes that the distance is in meters. So in order for that formula to work, x has to be in meters. So are there any questions up to this point about the objective, the hypothesis, or kind of how we're planning to actually do this experiment? All right, so what I'm going to do now is I'm going to put you all into breakout rooms. And in fact, I'll share the screen one more time here. So you've got this on the next page. It's like, oh my God, submit PDF of rods and cones lab objective hypothesis and procedure. So you will work with your lab partners in Zoom breakout rooms and develop so you basically, over the next like 25 minutes, you guys are going to write out in your lab notebook the objective, the hypothesis, but in this case, you're also going to have to write the procedure, because that's something we've all kind of worked on together here. And upload that. And then what we're going to do for the final part of the last 10 minutes of the lab is I will just, we'll go over briefly what the actual data looks like when someone gets it. So you'll have that in order to continue with your write-up. But so for the next 25 minutes right now, I'm going to throw you all into random breakout rooms. And just work together, and make sure you're all on you all reach a consensus. Make sure all of your objectives and hypotheses and procedures should be substantially the same, right? Make sure you all agree on what you're doing together. And if somebody's not clear, or you have, you can discuss it and converge. And I'll be here if someone has questions, so you can raise your, ask me.
Should we do sources of variability as well, or just the objective hypothesis and procedure?
No, sources of variability are important too. I mean, that's just going to be a few things.
Okay.
All right, here we go. So you can, it's, actually developing a protocol and writing it out is more involved than you might think, because you got to make sure that there is no confusion about what to do when somebody, whether you or somebody else who's administering the experiment, you want to make sure that they're following all the steps exactly, that there's not any ambiguity about how to proceed, because otherwise you wouldn't be able to compare data from different trials, right? Or you might have sources of variability that are getting folded in that are messing things up. So it's, and the reality is, even if you do your best at this point, sometimes as soon as you start doing things, you realize that you need to fix something. So, all right. So for the last few minutes here, and I should mention, if people have not, I would like you to submit those. I'm assuming that you have it pretty much done. Please submit the PDFs like when we're done with our talking in another 8 minutes or something, and that means it's off your plate. The nice thing about having this done and turned in is that it's done and turned in. Although I will be looking them over and maybe giving you feedback if it needs to get revised in any way.
I wrote mine kind of just like in paragraph form just to get it down. Should I rewrite it kind of how you have yours written, where they're like numbered in steps?
Yeah, I would definitely do it like the way you do it in the lab, like step 1, step 2, step 3. It should definitely be some kind of a recipe like that. Because again, somebody is supposed to be following the protocol, so they need to know what they do first, what they do second. All right, so let's look at the data. So the other thing you do once you have your, this is something you're going to turn in after. The first thing I want you to submit is just your objective, hypothesis, source of variability, and procedure. But then you are obviously going to have to do the rest of the write-up. And that's going to be from this data here. Here's the data from one of the earlier classes. And here is just the distance that it fell. These are 6 different subjects. This is the average distance among all those. This is the average, the time if you do that little equation. Obviously it's, there it is. You can see it's the beauty of Excel. You just put it in there, and, I'm saying make sure you realize light levels, 1 is the dimmest, 5 is the brightest. And here, if we look at light intensity from 1, the dimmest, to 5, the brightest, the distance it's fallen is much shorter when it's brighter compared to when it's dimmer. If I do the calculation with time instead of distance, we get this. Here is the amount of time before they caught it, about 0.35 seconds under the dimmest, about only 0.2 seconds in the brightest. So what is this telling me? Is this supporting my hypothesis or not? Yes, no?
Yes.
Yeah, most definitely. And then if I want to double check to make sure that the practice is not really a confounding variable, I have 2 other graphs here. I have this practice versus distance, or more relevant, practice versus time, since time is what we wanted. So if we just look at trial number, so we can see it was slower, faster, slower, faster, slower. So there was no obvious relationship between how many times they'd been doing it and how fast they were. Or if there is some relationship, it is dwarfed by how much of an effect the light had on the reflex. Right? So like in your discussion, you need to make sure you discuss how the data speaks to your hypothesis and your objective, and also about kind of the other stuff, how how we've worked around, making sure we can say these sources of variabilities are not problematic. So, I mean, what's kind of fun about this experiment is that we always get really solid data. And it's something you might not actually be as aware of. Like on a practical level, this is saying if it's dim light, the same reflex is taking twice as long to compared to if it's brighter light, right? Let's say you're driving. If you're driving at twilight or something, you see a little kid run into the street and you put down your brake, it's going to take you twice as long to stop, right? Before you actually can respond to this visual stimulus. Actually, we can actually bring something up. Why do you think it's more likely people get into accidents at dusk versus nighttime? Like dusk is like as things are getting darker.
People don't put their lights on at dusk.
Right. So at dusk is when you're getting into this dim light, slow reflexes. Once it's actually getting dark enough, you put on your headlights. Now, what is that? What receptors are seeing that kid running out into the street? It's going to be cones because they're brightly illuminated in your headlights, right? So, but I mean, this is on a practical level. This kind of data is really useful just in realizing, knowing your own limitations. Under dim light conditions, you are going to be twice as slow pretty much at reacting to visual stimuli. Any other comments or questions about this one?
Yeah, I have a question. Should we wait to do the full write-up until you've given us feedback on the procedure?
Yeah, that's actually a good idea. So I will be, so turn in, please submit those PDFs of your initial things right now. I'm going to end the class in just a few moments. And once you get feedback on that, you'll be good to go to finish up the write-up and do the complete submission, which I'll activate that link in a few moments.